probably a good time to get things started here. And I'm going to first welcome everyone and thank you for joining us today. Understand certainly is a busy day, or every day is a busy day for you, so we appreciate you taking the time out of your schedule to join us. Terry Biederman, who will be presenting today, is a GE Intelligent Platforms Global Industry Manager for water. He joined GE back last year in March. Prior to that, he was the Director of Public Works for Waterford Township, Michigan, and held that position in similar positions of moving up the ranks there for about 16 years or so. And he was responsible for the operations for Waterford Township, Michigan, including water, sewer facilities, and operations divisions. So Terry is a person who's not only familiar with the technology, which he will go over today in large focus of his presentation today, and the technology that's available to kind of help streamline public utility operations. But he's a person who's walked the walk and talked the talk as well. So he's in addition to Waterford, he's also spent time as a commissioner, Division of Water and Waste Services. He's been an engineer. He's a professional engineer. So he has all the credentials and actually the practical experience necessary to talk intelligently and with very specifics around these technologies, because he deployed many of them at Waterford. So what I will do is hand things over to Terry.
Okay.
And you should have it. And again, just a reminder for those that just joined us, hold your questions. You're on mute. Hold your questions or post them in the chat, and we'd be happy to answer them at the end of the presentation. So go ahead, Terry.
Hey, good morning, everybody. As Mike was... Oop. You hear me? You still hear me, Mike?
Yeah, we can hear you. You're good.
Okay. As Mike was saying, I spent, before I came to GE, I spent 26 years in the sector. My first 10 years at a county agency where we did both water, wastewater, and then I moved to Waterford as a Director of Public Works back in 1996. Throughout the career, obviously, I've run the utilities and dealt with all those things, but I've also designed probably over $200 or $300 million worth of water, wastewater facilities. A lot of operational experience, which was really, really good in terms of design. You know, when you start to design things, to understand the operations end of it is really good as well. So, a lot of the things that I'm going to show you and talk about today are really based on, you know, when I was a director and I was in that world, solutions and things like that I was looking for to help me with leveraging SCADA investment, technology investment. I don't think there probably wasn't a business process that we had in Waterford, which was a city of about 74,000 people, that wasn't touched by some form of technology or automation. So with that, we'll kind of get right into it. The agenda, what we're going to do is we're going to go through obviously who GE is. It's a couple of brief slides. We'll do a Proficy workflow deep dive, which will kind of outline what Proficy workflow is, and we'll actually go into Waterford's use case on that, and then we'll conclude it with real-time operational intelligence, which is a concept which is actually comprised of a portfolio suite that we have that makes up that whole concept.
Terry, you might want to share. I don't know if you've shared yet, but you have to share your presentation.
Oh, I thought I did. All right. Let me look here. Bring it up.
There you go.
Can you guys see it? Okay. All right. Let me bring it back up here. My screen went black for a second here. All right. Where's my PowerPoint? Okay. Sorry about that, everybody. So at the end of the day, what we have is GE. We've been around for an awful long time, founded by Thomas Edison. I think probably most people know the story. J.P. Morgan kind of kicked him out of that, but he was the original founder of it. We are a global leader in HMI SCADA. We invest millions and millions of dollars each year in both PLC control and automation software. Most of you probably know our iFix HMI SCADA product out there, along with our Historian product and those kind of things, along with our PLCs. We Intelligent Platforms is under the energy group of General Electric. We are not part of GE Water, even though obviously there's GE Water, which does a bunch of water treatment and those kinds of things. We do work with them on a lot of projects. So specifically, Intelligent Platforms, which I'm in that company, we are comprised of three major businesses: software and services, which, like I mentioned earlier, would be HMI SCADA, automation controlled software, and those kinds of things. Our control and communication systems, which are basically the PLCs and I/O and those kinds of solutions, and then we have a defense and aerospace embedded computing group as well. So we'll get into the presentation, and this is really kind of setting it up in a lot of ways. You know, water utilities spend over $1 billion a year on controls and IT, with the goal of, you know, becoming more efficient, consistent, and accountable. You know, the truth is, though, these solutions really only deliver so far, because at the end of the day, they're not integrated, and they're not able to leverage their full potential. And what this screen kind of summarizes what I'm really kind of talking about by not being integrated. You know, you've got your business platform at the top here running, you know, if you can see this, you've got everything from like geographic information systems to computer maintenance management, document management, you know, automated meter infrastructure, your payroll, your financial systems, AVL, vehicle location, and you got, in this case, these are shots actually from Waterford's implementations, and this is a broadband wireless wide area network. These are cameras that are streaming video in real time back to the office or onto their mobile devices or whatever. And at the bottom, you've got this really expensive investment in the SCADA and automation technology, right? You've got your SCADA systems, you've got your PLCs, and then in the middle, you've got modeling. If for those utilities that are modeling hydraulically, like say their water system or their sewer system, and the dashed lines really represent very limited connectivity between these platforms. You know, for instance, if the engineering group was running a water model, they may contact the automation or the SCADA group or the water treatment group or whatever and say, you know, I need some pressures and flows and some tank elevations to run this model. Well, what we're kind of talking about taking and leveraging that would be to have that happen automatically, so that the model just reaches out and grabs those data points as they need. And then the same thing with, for instance, computer maintenance management at the top of the screen. SCADA, you know, really, at least in the utility where I was at, you know, probably resulted in 30% or so of the work orders created each year. And to automate that process in terms of having the SCADA system linked with computer maintenance management is incredibly important and efficient, right? So if you've got an alarm or an event, why not have it automatically, why not have SCADA get a hold of your computer maintenance management system, create that work order, and put the necessary information in there for the operator. And that's what we're going to be talking about with workflow. So what we're talking about really at the end here is bridging all of these large investments and making them work and talk better together. So what we have here at the very beginning of the value chain are the PLCs and the control part of your assets. You know, your pumps, your blowers, VFDs, all of those kinds of things. And on the left-hand side is a quote from a utility. You know, my controls are reaching the end of life. And statistically, a lot of PLCs and a lot of RTUs and things like that are beyond actually the end of their life. You know, they were implemented in the 70s, late 70s, early 80s, and there's an awful lot of risk associated with continuing along those platforms and not upgrading. And so what happens here is you obviously are facing unpredicted failures, obsolescence, the ability to not be able to take the data that these PLCs are, bringing in and utilizing to do control, and you're not able to leverage that through, for instance, historians, and then to use it for analytics in the future and those kinds of things. So, if the car at the beginning it doesn't have an engine in it, you're kind of looking at a car without an engine. So that's the beginning of the value chain. And then we move into the next component where we talk about, this is the city of Detroit, actually, the wastewater treatment plant director there. That's about a 1.2 billion gallon a day wastewater facility. It's one of the largest in the world. They were still hand creating 60-page operational reports every 6 hours, and this was after a SCADA upgrade of over $20 million like 3 years ago. And what was really happening, and what's really happening there is that if you go and look in the upper right-hand corner here, you see again the various groups and that within the utility, like asset management, the business side of the world, like your financial packages and those kinds of things, SCADA, engineering operations, which could be the modeling and those kinds of things. And what you have in the middle are the collaborators. And this is what's happening traditionally is these are the connectivity points between these systems. And obviously, I think everybody understands that that's not the most efficient or effective way to utilize these platforms. And so what happens here a lot of times is you have communication issues between the groups. You see duplicate effort happening all the time. You have information silos, and all of that results in analysis gaps, operational inefficiency, and reactive operations. So moving to the next slide, again, this is the City of Detroit's director. He happened to be on a roll that day. But I know I can save at least $1 million per year on oxygen use and wastewater treatment, but I don't have an analysis capability to optimize it. Again, going into the upper right-hand corner here, you've got these disparate systems again, asset management, business, SCADA, engineering operations. And what you need to have if you're going to perform an adequate analysis, again, is you want the whole story, right? So data to perform analysis and those kinds of things may need to come from multiple sources. And if they're not talking or communicating with each other and pulling the necessary data in that you need, then you're going to have an incomplete and inaccurate analysis, which means you're not fully optimizing your processes and those kinds of things. Here's where we get into the mobility side of the world, and this is actually a quote from me before I actually came to G. If I could get operational information directly into the hands of the people who need it through mobile applications, we could save tremendous staff time while increasing response time and operational compliance. Again, traditionally you've got operators, looking, and I call it watching TV. A lot of them are sitting here, they're watching all these multiple screens, and I think most people out there realize that most studies show that really people aren't able to absorb all that information. So what happens is that they're actually focusing on a couple of screens that they may create that really are kind of like little dashboards for them, and the rest of it's just looking like a command and control center. So with this, you've got assets in terms of people and knowledge sitting in control rooms that could be liberated and out into the field with an iPad or a laptop or whatever, performing higher value work and actually acknowledging alarms or doing whatever they've got to do that they're doing in the control room, as well as mobilizing the collections workforces and the distribution workforces with mobile applications out there. So, what if there were solutions to control, integrate, and mobilize these systems to leverage their information and provide advanced analytic capability? Well, the good news is that there is. And beginning this journey again, starting at the beginning of the value chain, which is the PLC, this is a quote from Ravana, which is a utility in Virginia. We need to keep running no matter what, and during the last hurricane, that's just what we did. What we're talking about here is PLC platforms that are robust, that are well connected, that are able to process the terabytes of information that these PLCs and the instrumentation and that can create. In addition to that, a modernization master plan. For instance, G's RXI PLC has a ComExpress technology that basically you replace the motherboard or the chipset if you want to upgrade the PLC in the future. Instead of replacing the whole PLC, we have a modernization plan for that, just replacing that chipset. And then, of course, system reliability. These are built to military-type grade specifications and those kinds of things. So, getting the beginning of that value chain set up and ready to go for all of the things that can come to leverage that in the future is incredibly important. You move from there to what we talked about before, where you've got the disparate systems and the collaborators. Here we have what we're calling really platform convergence, providing staff with collaborative information, allowing them to better serve their customers. So in the upper right-hand corner, you've got wells and treatment plants and pump stations, all the traditional operational assets and those kinds of things of the utility. And on the right-hand side, you've got the computer maintenance management systems, the laboratory management systems, automated meter infrastructure, and so on and so forth of the business side of that utility. And obviously, you see the SCADA and the operators, the traditional view in the middle there. But there are two little components here, and they're not little, but they're very important. They're little in the graphics, I guess. But Historian is one of them, right? Historian is an incredibly important tool that it's allowing you to collect all of that information. And without Historian and that information, I call Historian kind of the gateway to goodness, right, or the gateway to excellence, because if you've got that information, you can obviously perform forensic analysis if something happens. But, what I'm challenging you to think is let's let it help predict and those kinds of things that can happen or are going to happen, using some of the tools that we're going to talk about today. And then the other component is workflow, which is the product we're going to go into a deeper dive on. Workflow is actually two components, and we'll get into that. One of them is service-oriented architecture, which will allow for the connection of the SCADA system to your business platform so that you could begin to connect these various disparate platforms and those kinds of things. And the other component of workflow is electronic standard operating procedure capability. So this gets in now to the analytics side of the story. Analytics, this is a utility in California. Analytics provides us with process visibility we never had. It has provided opportunity for increased efficiency. So again, using real-time and Historian data from relevant systems, you can perform powerful process analysis and those kinds of things. So you can optimize processes, you can have better regulatory compliance, and those kinds of things. And if you take a look at the screenshot, you'll see, for instance, at the bottom is ranked causes. So as the model gets more and more data and it begins to learn, it knows what tags you're looking at in the SCADA system to perform this analysis. And if something deviates, it can actually rank the most probable causes of failure and help the operators to basically correct the problem more quickly. And then we go to mobilization. Mobilization empowers my team to make more accurate decisions quicker, which increases overall service levels to the public. Again, it's basically mobilize. There's several components to it. We'll get into real-time operational intelligence, but one of them is the very basic component of that is just mobilizing your HMIs, getting them out there on iPads or laptops, and with all of the same security functionality and all of the same graphics and everything like that you enjoy now on a thick client type of a setup. You can certainly do that through our mobile application, and then so. Obviously, if people are in the field and they have that information right there at their fingertips, you're talking about KPI, key performance indicator visualization, intelligent alarming, workflows that we're going to go through, and all of that kind of stuff right there. They're going to be much more able to respond to things quicker and in a more intelligent fashion. So what can we impact? Just to summarize this real quick, we talked about improving consistency, efficiency, and accountability. And, in the middle here in the benefit areas, just kind of use your imagination, but here's some examples. Repeatable filter backwashes. I know that in water facilities, and I can say that in my utility, I had 13 water treatment plants, and everybody backwashed, for instance, a plant differently. We actually fully automated several of our water plants so that we didn't have to have an operator there to backwash. They would backwash on filter run times and or filter differential pressures and things like that. But to make a long story short, you got an operator that comes in and says, I'm going to backwash this water facility, every Friday morning, and I'm going to do each cell 30 minutes, whether I need to or not. Ultimately, you're spending a lot of money on energy and water that you may have to have treated at a sewage plant or whatever to do that backwash. Where if you use some of the instrumentation and some of the things that we were talking about in our applications, you can actually create a procedure that basically walks that operator through the best practice, so that, first of all, you don't backwash if you don't need to, and secondly, you're going to do it in the most efficient manner every time by everybody. And then you just kind of carry this through. In the green, the operating efficiency. Improved chemical feed. Again, most utilities overtreat. They don't have the resolution to optimize alum feeds or ferric feeds or even chlorine feeds or orthophosphate or whatever. So if you put PID control capable pumps and those kinds of things on these, and you're getting feedback of, for instance, incoming strengths of BOD of the wastewater plant or those kinds of things, you can actually begin to optimize those chemical feeds, which then, of course, reduce energy. They reduce chemical costs, and then they reduce the sludge that's produced from the process. And then carrying it all the way down to the bottom, accountability, which is really one of my, being a director and those kinds of things, reduce my cost of regulatory compliance. Every year, I think you guys all know that you're getting hammered with, new, Safe Drinking Water Act, things you've got to monitor. You've got your NPDES permits you've got to worry about, and all those kinds of things. And so, you can, to control that and to bring that cost down and to optimize that is a good thing to do. Better maintenance planning, of course. Better department coordination, because you've got these systems talking to each other. You're helping to leverage the departments out there and for them to be more effective. And then, of course, to reduce asset downtime. So with that, we'll get into workflow, and we'll start that out now. So what is workflow? I mentioned earlier that workflow is composed of two components. If you read the top paragraph, the first one is the electronic standard operating procedure part of it, which enables you to create an environment of information-rich, circumstance-based workflows that operators can follow to best understand what's happening around them and react in a sequenced and procedural manner that is repeatable every single day and every single time. The other component of it is the service-oriented architecture, which is we call it the glue that's going to allow you to connect to many existing, anything that's ODBC compliant, OPC compliant, it's going to connect to it. And business platforms and water and wastewater treatment plants, obviously both from GE and third parties using the service-oriented architecture. So when we look at Proficy Water operations workflow, we're really talking about decreasing downtime, maintenance, and costs across the entire operation. And that's done through manual task automation, electronic standard operating procedures, alarm response management, centralized operator interface. So if you take a look at this screen here, this gets into kind of, say, the manual task automation. So if you look at the picture, and we got some blow-ups later on, but right now, if you like the very first one, a detailed step-by-step outline of what steps or what processes you want an operator to follow to solve to resolve a problem. If you take a look at the screenshot on the right, the left-hand side of that, you can see the light blue steps. Those are the major steps that the operator would be asked to perform, and they're all time-based as well if you want to make them. So, for instance, if you've got a really, really critical workflow that comes in that you've defined, and you want it responded to and resolved, say within 4 hours, if it's not, it can be elevated up to a supervisor through an email and those kinds of things, letting them know that this workflow is still outstanding. So what it really creates at the end of the day is it allows you to create what I call virtual operators, a lot of virtual operators and a lot of virtual supervision in terms of, are these things getting done? Are they being done the way that they're supposed to be done? And what that does is it's going to complement your staff. It's going to complement them and help them to focus on other things. Not sitting there looking at staring at and trying to figure out relationships between various processes, they can actually let the workflow that you create do that for them, and then if it detects that deviation, alert them and walk them through how to solve that. So on this screen here, this is just at the top one here, it's kind of a picture of, if you look at the right-hand side of the screenshot, the white area is kind of the specific details of one of the steps on the left-hand side, and this looks like the first one's one highlighted, the step one. You can embed your HMI screens or HMI type of graphics inside of this. So, for instance, if one of the steps is that the operator has to, turn a pump off in order to, perform, to complete that workflow, if they, again, have the security privileges and things like that, they can do that all from within the workflow environment. And if you go to the bottom one, again, if you're not using, say, iFix, our Proficy iFix HMI or product, we don't have a problem with that. We will embed third-party HMIs. It could be RSView, Underwear, or whoever. So it's a completely agnostic environment that's open. If we go to the second part of it, we're talking about scheduled, daily, and SCADA activated tasks, keeping operations and operators focused. In this case, again, if you take a look at the top one, you've got simplified steps for the operator with detailed information in the work instructions. So if again, you can see, I think it's the fourth step down that's highlighted, and then on the right-hand side are the specific instructions of that step. They can be as simple as you type in instructions as part of the workflow definition. You can bring in a scanned SOP that you've already got. You can link it to a document management system if you want to bring that in. All of those kinds of things are fair game in this environment. The other thing is, in the middle, this is all a web-based interface in the white space. So, for instance, in the middle screen, if one of the steps, let's say that the workflow that you define as a caustic chemical, spill or something. Let's say it's ferric or even chlorine gas, right? If the operator, if you feel the operator needs to be able to access MSDS information on that particular substance as part of the workflow resolution, you can link, for instance, to an online MSDS program like we had in Waterford. Everything was online for us. But you can bring that right into this environment. You could just bring in the sample or the simple scanned-in MSDS page for that specific chemical. You can also bring in at the bottom live video. So, like if it's a process where maybe it's a workflow coming in, a smoke detector goes off at a remote facility, and you've got a camera in there, and your workflow is a response to a fire, basically, at a facility. I mean, you could bring a video feed in to actually confirm that maybe something's on fire. So we've actually got customers using this workflow totally for video surveillance and security and walking their operators through the processes of reporting and doing whatever they need to do if their properties are breached by someone. So we can move from there into alarm response management. Again, at the top, automatic excursion of detection begins the troubleshooting workflow. So you define a workflow, and they can be as simple as pump runtime thresholds for maintenance. So let's say every 500 hours, these high service pumps, you want the O&M manual calls for these specific maintenance steps to be performed. Let workflow take care of that for you. So once the totalizers in the SCADA system reach those thresholds, the workflow will be triggered, and then walking the operator through the standard operating procedures to perform that maintenance. You can even embed the O&M manual if it's digital if you want. You can put a video on there. For instance, they got to tear the pump down, and you got a training video showing them how to do it, you can embed the video in that workflow as well. The example at the top actually is bringing in real-time values from the SCADA system. So when the workflow gets created, the operator can then basically see what parameters triggered that workflow in real time. In the middle, you're looking at a trend. So again, if you've got if you're doing historical archiving or trending, you can actually bring the trend into the work environment for the workflow resolution, and you can see, so if the operator wants to know when that deviation occurred, or he wants to see the process before it happened, instead of leaving the workflow environment to go look into the HMI, it's all contained right there. And then at the bottom, basically, you've got the capability of just typing in notes and creating a log if you want. If the operator just says, yeah, this is what I did, and you want to close it out, it can be as simple as that. The other thing that we provide is full electronic verification. We have several customers that one of the very first steps of their workflow processes create an e-verify of who the operator is that's responding to it. Because a good example would be you're at a wastewater or water facility, and a super user is logged into the SCADA system who has rights and privileges to everything, and they walk away or they leave and they forget to log out, and something happens and an operator comes along that doesn't have those privileges and says, hey, I can fix that, and pushes a button and some bad things happen. I could say from direct experience, you're going to get a lot of finger pointing saying, well, I didn't do it, I wasn't logged in, and those kinds of things. So by just creating an e-verify type thing, you can do that as well. And then we get into talking about linking workflow with SCADA systems, LIMS systems, not SCADA, but, SCADA obviously, LIMS as well, laboratory management systems, as well as computer maintenance management systems. So in this case, this would be an integration with in this case, this is a Waterford example, a GIS-based computer maintenance management system, which happens to be CityWorks. However, for instance, like the city of Cincinnati is using workflow with Maximo. People are using it with Infor out there. There's, again, if the work order system is ODBC compliant, open and relational database, and all OPC compliant, all those kinds of things, it's not going to be a problem. We could even connect to ones that are proprietary, but obviously it's like everything else, it'd be additional effort. Moving all the way down again to the bottom here, provide detailed work order instructions for maintenance and calibrations, for instance. So this is the next screen is going to take us to enhancing SCADA with just the electronic SCADA operating procedures. So you define a workflow, and in this case, the example is a caustic chemical out of spec workflow. Obviously, the workflow runs 24/7, 365 days a year, continually running its algorithm, looking at your SCADA system to see whether or not it's in compliance or not. When it sees that it's not, so in the middle there, the out-of-spec data triggers the workflow. The data then triggers a caustic chemical feed out-of-spec workflow, which then automatically goes to the right-hand side, if you define it that way, where the workflow sends an electronic standard operating procedure to the operator, and that contains the instructions and those kinds of things to resolve it. So the operator goes out, performs, in this case, 4 steps, and sends an email to maintenance to solve it or to resolve it and close out the workflow. Here's the same type of scenario, only now what we have in the middle in the purple is the CMMS portion of it, computer maintenance management. So the event that's defined example here is a pump runtime out of spec. It goes from there, once the system detects that, it triggers a the pump runtime workflow. But before it goes and sends the electronic standard operating procedures and other things to the operator, it's going to go ahead, first of all, and it's going to request a work order from the CMMS, a work order number, and those kinds of things. So it's going to talk to the CMMS, get a work order number, and grab asset information. And then ultimately when it has that, it's going to forward all of that information. The workflow is going to send the ESOP, work order number, and GIS asset information or asset information to the operator. The operator then goes out to the pump station or wherever the problem is, performs, in this case it's a five-step ESOP, completes the workflow, closes the work order. So what you have in this example is the entire value chain of monitoring the actual asset like a pump, and then carrying it all the way through electronic standard operating procedures of how you want the problem resolved, and then capturing labor, material, and equipment used in the CMMS system of what it took to resolve that. So the architecture obviously gets a little more quite simple compared to where it was. Yesterday, you had all these point-to-point integrations which required custom interfacing and custom programming and those kinds of things. Today, with our service-oriented architecture approach, SOA just kind of sits in the middle, and it provides those hooks into each of these platforms, which is much cleaner. For instance, you'd wind up configuring, for instance, like in a computer maintenance management system, one of the things you get from them would be their advanced programmer interface for maybe their metrics portion of it or whatever. But to give you an example, in Waterford's case, we interfaced workflow with CityWorks computer maintenance management system, and it took about 3 hours to get it talking and creating work orders from the SCADA system automatically. So here's just kind of a blow-up of some of a workflow screen that I was talking to you guys about earlier. So this happens to be a high-carbon one-filter effluent turbidity workflow. I think this is by a water treatment plant, Haverhill in Massachusetts. So on the left-hand side, you see the task steps, and if you look in the upper right corner of that box, you see like a little rectangle with a green bar in it. That's the amount of time that the workflow definer allowed for that step to be completed. So if that step doesn't get completed, a supervisor can be notified, letting them know that it hasn't been completed. And as you can see, step 1 is highlighted. So obviously, this is a workflow saying that the filter effluent turbidity has exceeded their limit of 0.5 nanoturbidity units, and or it's out of service. And this is actually the real-time value of the filter turbidity. And in this case, we talked about the e-signature or verification. This one, actually, they want the operator to enter their name before they perform any work, and then to enter any dates. I mean, again, these are open templates for you to define any way that you want to do it. Here is obviously workflow comes with reporting capabilities. If you want really, really detailed reports, it's a database. You can use crystal reports or whatever you want, and you can mine specific reports if you want. But in this case, this is the kind of on the left-hand side. It's the workflow name, its start time, its end time, duration, and so on and so forth. And then the little screen that pops up in the middle, again, are the workflow names, how many times they've happened in a specified period of time, the average minutes that they've taken to be resolved, the minimum minutes they've been taken to resolve, and the maximum minutes that they've been taken to resolve. So with that, we're going to get into the Waterford Township use case. Again, here's a little overview of Waterford. Waterford is it's in Oakland County, Michigan, which is about 35. The Waterford itself is about 35 miles northwest of the city of Detroit. 74,000 people, 36 square miles. In this case, you've got about 360 miles of water main, 350 miles of sewer, 19 production wells, 13 iron filtration plants, high service pumping stations, 63 sewer stations, and so on and so forth. So the project objectives here were to create electronic standard operating procedures to capture the real-time events and document the best practices to resolve them. The middle one was to provide a workflow component for SCADA, auto task generation. What that means is scheduling. So workflow can also be used as a scheduler. So what the middle one meant was they wanted to incorporate pump station inspection inside the workflow. So instead of inspecting pump stations every week, whether they needed to or not, which consumed an awful lot of time, they actually created schedules, and they had the workflows generate that schedule and notify the operator of when they wanted that station inspected. And they actually they created their own pump station inspection form inside the workflow. So the operator would go out with their iPad to the pump station when it was called to be inspected, and they would enter the information right there in the workflow in the form that was in the workflow, and they would close it out, and they would be done. And then the bottom part of it, the third component of the objective, was to integrate it with their SCADA or their computer maintenance management system. In this case, CityWorks, and they used the methodology basically of using the CM or the CityWorks work order API which is one of the methodologies that they use to make that happen. So again, the project overview. Obviously, everybody knows what a SCADA is. In this case, we're talking about the monitoring and control of the system. In the middle, obviously the alarms generated a large proportion of CMMS work orders, like I mentioned earlier. And in this case, they're really, like most utilities, you've got standard operating procedures and you got emergency response plans. And I think everybody here, if they're being honest, knows that most of the time those things sit on the shelves as giant paperweights. So here's an actual opportunity to really make that live and dynamic. You can actually bring those ESOP or those standard operating procedures and those emergency response plans to life with workflow. And then obviously workflow at the bottom, we talked about what that was, manual task automation and so on and so forth. So again, on the overview, CityWorks, the work order API provides the developers the supported set of web services to generate work orders in CityWorks. And really it's the same for, CMMSs such as Maximo or, any of these other ones as well. You're going to utilize the inherent CityWorks business logic or your inherent CMMS business logic. You don't want to recreate the CMMS. That's not what this is all about. So you're going to leverage that system. And then the third component is it's all web-based. So the web services follow the JSON standard, making them language independent and able to support requests generated from a variety of environments, including .NET and Java. So phase one was keeping it simple. Just doing some simple stuff. They called in, actually this would have been me because I implemented it, but we called our sewer station operators in and we said, hey, what are some of the things that are really taking time away from you in a day that, a lot of times you miss and those kinds of things. And one of them was with 63 sewer stations, they'd have to come in several times a day and just simply look at the pump run times at sewer stations to make sure that they were, fairly equal, right? Meaning, in a sewer station, just looking at a two-pump station, if you're alternating pumps like we did, we want to maximize asset life, so we run pump one, and then we run pump two, and then we run pump one. In a given 24-hour period, they should run within a few minutes of each other because the diurnal patterns are the same. If the pumps are the same size, and they should be if you're in permit compliance and those kinds of things. So that was an easy one. That's a simple workflow. All that really amounted to is writing something that basically said, take the absolute value of the difference of the run times, and if it exceeds 25%, we want to know about it, and let this thing run on all 63 stations continuously. The other one was the pump number of starts, and again, that's all alternation. If you've got mechanical alternators in your pump stations, then sometimes they go bad, and they don't alternate and fire the way that they're supposed to, which obviously will affect run time as well. So again, instead of having to look at it and make sure these pumps are alternating properly, which is really a sign of a problem that could turn into a much bigger problem in the future, let the workflow catch that. As I mentioned earlier, the third one here was workflow. It does not have to attach to SCADA or anything. It can be a standalone process, and in fact, in this case, they wrote one for sanitary sewer overflows, meaning that, they don't happen very often, and when they do, there's obviously a lot of regulatory and public notification that you've got to do in order to comply with that. And so it's a process, so a perfect candidate for a workflow. So in this case, if an SSO happened, there's just an icon on the desktop, the risk management person would come in, execute that, and the workflow walked them through the steps of regulatory notification. It actually brought the forms in that the operator needed to, or the risk guy needed to fill out for that, and you could email right out of workflow. So like once that form was completed, he could email it right to the regulatory person. And then of course, like we mentioned, these are all time-based activities, so you've got the log of when that was actually sent out. Same thing with notification of newspapers or the language that you want to include in that notification can all be contained within that. The other one was site inspections, and I talked about that quite a little bit ago, where they actually used workflow to schedule pump station inspections, and they created their own pump station inspection form inside of workflow. And then phase two was to integrate document management because instead of like hyperlinking a bunch of documents and those kinds of things, Waterford had a very robust and sophisticated document management system. Instead of they just wanted to link that. So like if something had to come in from like an O&M manual that was digitized, that would just come in from the document management system. And then of course to develop additional workflows by internal staff. So workflow components, there's really four basic components, and they're comprised of the equipment model. In this case, the workflow model is based on IS 95. It's the industry standard data model. So it's not something that's created and proprietary to workflow. This is actually based on an international data model. It's also based on events, such as conditional expressions or time-based that trigger the workflows. Schedules, like we mentioned earlier, you can combine workflow or events with workflow templates to initiate workflows based on time. And then, of course, your templates. In this case, you create the template. So let's say you were doing a workflow on pump run times for sewer pump station 1, the runtime comparison. Once you created that, basically, if you've got 63 other stations or whatever, you can pretty much duplicate those workflows and just change the tag names from your SCADA system to monitor the appropriate asset at the station. What that means is that the workflows can be created very, very quickly. So here's kind of a walkthrough on the workflow equipment model. So this is if you just take a look at the top here, you've got enterprises, and in this case, it's the Department of Public Works, sites, and then it's broken down into sewer lift stations and water treatment plant. And then the areas, you see sewer lift stations is highlighted. And so the areas are all of the sewer pumping stations. And then you see here, the specific one that's highlighted is 3-3 Lamson. And then inside of Lamson, these are the pieces of equipment that there is SCADA, real-time SCADA information for that's been defined in the data model. So you've got electrical information, you've got generator information, you got pump 1 information, pump 2 information, and a wet well information. And so if you go to the bottom, the SCADA information, as you can see pump 1 is highlighted. If you go to the bottom, you see the actual tag information from the SCADA system of what's needed in this workflow. And one of them is auto status. Well, you need to know whether or not the pump is in auto to perform the calculation, because if it's not in auto and offline, you're certainly going to get a discrepancy in runtime. So you want to know whether it's in auto. And if you take a look, as you go across there, you'll see the value. That's the actual tag from the SCADA system. Then you got runtime, and of course the tag from that is the totalized value from the SCADA system. And then you got starts, which is the number of starts from the SCADA system. And the bottom one is a question that we ask as part of the logic in the workflow, and that is the workflow already running? So if a workflow gets created because of pump run times, every time the pump comes on until an operator can get out to resolve it is going to increase that discrepancy, and workflow would get generated again. So what this logic means then is that if a runtime workflow gets created, we don't want any more created until the one is resolved and we reset it. So they don't get bound with a bunch of nuisance ones. And what this screen shows here is the actual test link between workflow and the SCADA system, and this is just showing that the data source, which is from the SCADA system, and that's 3-3 pump 1 number of starts. The communication test was successful. Here is just a conditional. We talked about the conditional side of this. These are the conditional steps. Again, a little bit of an outline here of the pump starts workflow for sewer station 2-1, and you can see the tab up here clicked on conditional expression. So all of these have to be true in order for the workflow to execute. That would be the number of starts. The difference of the number of starts between pump 2 is greater than 25%. Pump 1 has to be an auto, pump 2 has to be auto, and a workflow can already be running. Now, when you get into actually building that numerical expression, again, you have all the mathematical functionality that you would want to build that expression with or need, and at the bottom you have the other expression names as well, like absolute value, rounding, all of those kinds of things, square root, whatever you want, and you've got all that functionality to help you write the logic of those workflows. Here just happens to be the scheduled ones. This is how you would set up a schedule. So this happens to be an inspection schedule for day 1. It's going to reoccur indefinitely. It's a calendar event going to recur indefinitely. It's going to start on 4/25/2011. It's going to happen at 7 o'clock in the morning. It's a weekly reoccurrence on Mondays. And then they actually said, even though it's weekly, they want to pop it on every 2 weeks. So you can actually go to one step deeper on that.
Hey, Terry, this is Mike real quick. Just a logistics point. It's about 10 minutes to the hour, so just want to give you a time check here. So.
Done with this, and I'll get into RTOI. Mike, how long? Because you had the opening till what, 12:30 or 11:30 your time?
Yeah, I mean we're good. I just don't want to, for the sake of the people scheduled, we've got.
Well, when do you want to end? Do you want to end this on the hour?
Yeah, pretty close to the hour, and then leave enough room for questions.
All right. Well, then we got then. Okay. Then if you want to end this on the hour, then I'm going to jump through quickly to get to RTOI then for the most part. All right. So yeah, you guys. The other thing is that this presentation is going to be available in a PDF for everybody. So this will be like the template here that it's kind of a drag and drop if you want to configure your own. And I'll walk through this really quickly. Here's an example of workflow deployed. This is an actual email that gets sent out telling the people that are in the list the workflow and the work order number was created. Again, this is an example of a pump runtime exceeded here. These are the steps that Waterford defined on the left-hand side, and this is step 1 is highlighted. So these are the specific steps within that one. As you can see in the tab, you got comments, you can email, you can do all kinds of stuff in there. This is workflow, like a summary dashboard of workflows that are out and outstanding, the name of it, when it started, whether it was completed or not, and so on and so forth. Here's an example of Waterford where they actually went through with, and they've created them for HVAC, they've created them for bankruptcy notifications, they've created them for grease trap interceptor inspections, pump station inspections, obviously. They're doing it for safety reporting, incident investigation, property damage, sanitary sewer overflows, and, of course, the pump run times and pump starts we talked about. This is a managerial dashboard. You can define it any way you want. If all you're worried about are wastewater ones, then, just set it up to look at wastewater workflows and so on and so forth. Here's an actual report mined from Waterford's work order system. This is for January of 2012, and these are the stations that had a pump runtime and or pump start deviation. And then you can see the labor, in this case no material because apparently they didn't have to repair anything. Equipment because you got trucks and generators that you may have to take out to the site. So you got the total cost and then total hours. But if you go to this slide, here is a work order report from the CMMS again, run for the entire year of 2012 for the pump number of starts and the pump runtime comparisons. 346 work orders were created from it, resulting in a cost of $2,800 to the utility, and you can see the breakdown between the two. This one here is the same information at the top, but this is for all 63 sewer stations. And if you take a look at the pie, you can clearly see 3 areas or 3 stations that were screaming for some help. And in fact, the one in the teal-colored green actually had, when the electricians went out there to look at that, there was actually arcing going on behind the backplane of the SCADA panel, which was a fire waiting to happen. If that station would have failed, probably 500 houses would have backed up. Just caught that. And this explains here what the pump runtime comparisons. What I did is I did a quick and dirty return on investment just for the pump runtime and for the pump alternation comparison. And to give you an example, just for the creation of these two examples, which only took a few hours, the return on investment for the whole workflow implementation at Waterford was only 4 months. That, like I said, that was just two of the simple workflows. And then this is actually kind of the spreadsheet that calculates that out. We don't have time to shoot through that right now. Okay, so what I'm going to do is spend 5 minutes on the operational intelligence part of this. So rethink your HMI SCADA and think it securely, okay? So what we have again is we got data everywhere to actionable knowledge anywhere, anytime. And this screen's a little bit busy, but this really summarizes it quite well. So you've got the data everywhere at the top, along with the actionable knowledge anywhere, anytime. So these are, it's context, organizational relationships. Again, it's built on that data model that we talked about. So you get to leverage that again here in this concept as well. It's role-based. We have a proximity awareness, and we'll go through that with a geointelligence patent that we have. It's obviously mobile. We can integrate our analytics packages with it, and it's all about collaboration. So some of the components of RTOI are our agent, which is our secure web-based agent, which is very, very robust. It's actually based on GE Healthcare's requirements for HIPAA privacy and those kinds of things. We've got the mobile key performance indicator capability, advanced alarming, because like 75% of alarms are noise. We actually have some algorithms that can help you guys define and reduce alarm noise. We've got a dashboard here called Vision that basically you can build your own dashboard summaries of what you want to see here. In this case, this is an example of a SCADA shot with an AVL embedded into it and a report. And then we have mobile notes. And then, of course, if you look at the bottom, one of the ones I want to point out, other Proficy components, which can be, again, workflow and some of our other stuff. So workflow fits into this as well. So what you have is a global view of your plants and sites. So you got your My Assets. Again, this is that data model. And it's drilling down all the way down to like the equipment level. And you build that data model. So you're going from structure to context, alarms to analytics to action, right? If you don't really care about the stuff in the middle, don't worry about it. You can take a look at the other parts of the asset in there. We also have a geointelligence patent for proximity awareness. So if an operator is walking or driving through the utility and they drive by a pump station or they walk by a piece of equipment at the plant, the right information at the right time can be displayed for them. As you can see, it's not if you look at the little iPad, it's not the traditional HMI. It's actually key performance indicators for that piece of equipment and its asset health. Is it performing the way that it should be, or isn't it? And so, again, based on where they are in their role. A little bit of a blow-up on it. Again, that structured navigational view, the data here. So, again, here's like a facility management. And then you drop down from facility management. Well, in this case, it's fixed. This is a fixed factory example. So fixed factory, here inside the fixed factory are a couple of things that they're looking at. And inside of that, you're drilling down into the actual individual assets. A blow-up of it again. This is actually a water authority in Texas. This is a you can bring trends in, all that stuff. So you've got the river authority. This is an explanation of what the river authority is. The key relationships, in this case, this is Lake Livingston Dam. And some of the key performance indicators for that are the daily load, electrical consumption, and then up here, if you can see the health risk indicators, based on their definition of it, right now it's in good shape. And they could bring in real-time charting of it if they want. And then you got an action bar and a task bar at the bottom. So again, 75% of all alarms are noise. We can help you find the critical few and basically display it as little icons like those kinds of things. So it's about getting any alarms anywhere, anytime. Alarm state aggregation, obviously, the red X, critical, orange exclamation high, and so on and so forth. So the operators, again, you got the example here. You've got this piece of equipment or this major area, and then breaking down to its KPIs and whether or not they're in good health or not. Same thing with health. You can actually have it as a little dial. So in this case, you can see it's beginning to lose health. So that could be like, for instance, based on pump run time. So if you've got a workflow that you create that says you want certain work performed after 500 hours and it doesn't get performed, you can begin to define, okay, well, at 600 hours, this is going to turn yellow. At 800 hours, it's going to turn red, meaning that it may not fail, but you're getting so far beyond your regular maintenance requirement for it that you're risking that problem. With it, you can also, if you want, at the taskbar at the bottom, if the operator wants to go back to the traditional HMI view of it, he can do that, or she can do that. They can just click on the button, and boom, you have your mobile version of your HMI there as well. With Vision again, here's an iPad with here's a treatment plant with a real-time camera being brought in, and so on and so forth. So you can display what is important to you by the role or privileges. We also have mobile notes if they go out to solve or work on something, and you want to capture, if the operator wants to put in, you want to capture some of the things that they did for future reference in that, you can do all of that as well. And then this just gets into the security part. I know I'm running out of time, you guys, but it's about making your connection secure and those kinds of things. So we do, there we go. It's really about our Proficy agent, it's digital certificate signed, 256-bit encryption, soft VPN, local to trusted. Now, I won't get into a ton of the architecture. We can certainly get people to talk to you guys about that. Again, it's designed for the industrial internet. We've got all of these certifications, all of these kinds of things. It's called secure transport, and so it's going to totally allow you to go to the web or whatever you want to do for your solution. And this is just kind of a little bit of an architecture thing, from yesterday. Your traditional plant sitting behind its own firewall, not talking to the rest of the world, to today, where you've got these things with our security or our secure agent and those kinds of things, allowing you to leverage and take advantage of all of these types of technologies. We are committed to cybersecurity. Again, here we do have a cybersecurity website, and that's if anybody wants to write that down, it's geip.com/security. And this is just an example of Haverhill, Massachusetts. They're actually using WebSpace, and as one of the things of the component of RTOI, real-time operational intelligence. They've mobilized their SCADA system. Now, they serve 58,000 customers, 6 on-call workers at the facility. This is basically their SCADA system at their fingertips. And this is a quote from the manager there. And then that's just a second. iPads are way cheaper than ruggedized laptops, and all those kinds of things. And they're fully beginning to utilize the type of technology. And with that, you guys, that's it. If you guys, whoever wants to look this up, at the bottom, if you take a look, I had an article published last month in Pumps and Systems magazine titled Real-Time Operational Intelligence and Aging Infrastructure, and that's the link to the web page, and Mike can get you that as well. He's got a copy of the presentation, but I think you'll find some valuable information in that article. And with that, questions, I guess.
Great. Thanks, Terry. I've got a couple of written questions, and then I'll open it up to those that want to stick around. I know we kind of rushed through things at the end there, but I still want to give you an opportunity if you have any other questions for Terry. But just a couple quick ones here. One, how did you convince the township that you work for to invest? What was the trick?
Well, first of all, there's several components to that answer, right? And it starts from the very beginning. Even just building a network to support all the stuff, right? So we very early went through and we created what we called we did a needs assessment that outlined technology and staffing and all those kinds of things, and we kind of used that as a blueprint to move forward. And then as you evolve, because this didn't happen overnight. The whole technology schema for the township didn't happen overnight. You evolve and you begin to implement these things, and then we would prepare reports showing, cost of savings and those kinds of things. And we prepared an annual report every year. It was about 94 pages, and we mined it from SCADA and computer maintenance management, from all of the systems that we had. But moving into the SCADA realm for like workflow and these kinds of things, first of all, these applications aren't really that expensive when you look at it. They're not that expensive. You'll be surprised, and Mike and those guys can get with you on pricing. But the ROI that I just showed you a few minutes ago on workflow demonstrated the case that 2 simple workflows basically paid for the implementation in 4 months. So all that information is there, and you just build that case. And we do have the ROI examples for that and for mobility. If you want to see those, we can get those to you.
Okay, great. And one other written question here: how did your operators react to the new technology?
Again, going back to the very beginning when we were, when the utility was basically in the Stone Age, it's a process, right? It's about building trust. It's about building relationships. But at the end of the day, and by the way, I extend the offer. Anybody who wants to, Waterford will be more than happy to do webinar, or you can do a site visit if you want. But you really have to you've got to change the culture, right? And you've got to empower the workers, and I actually did a presentation on that as well. So, I have that one too. But at the end of the day, they saw the value in it. They realized that it was helping make them much more efficient. It was actually doing a lot of the crazy, boring, routine stuff for them, like checking run times. And, you start to build that intelligence and you begin to manage by exception. They're able to do higher value stuff instead of sitting there looking at computer screens all day. So they actually like it a lot.
Well, thank you for those of you that joined us today. Hopefully it was informative. I know there was a lot of material to digest, and there's a lot of information kind of being pushed together at the end, but I appreciate your time. And as Terry offered there, certainly feel free to contact him and as well as any of our INS account managers that I'm sure you know or have relationships with. Certainly feel free to ask them questions as well, and we're happy to follow up with you. So thank you again. Have a great rest of the day and a good weekend this weekend.
All right, thanks everybody.